BIMCafe talk. Today we are hosting a talk with Kean Walmsley from Autodesk. And Kean, could you present yourself and let us know why you're joining us today and how did you become the Autodesk professional as you are today?
Oh, wow. Well, hi, everyone. Thanks for joining this session. So I joined Autodesk a long time ago. You can hear me okay, right, Asker? Is it all right?
Yeah. Everything is
okay. Perfect. Yeah, so I joined Autodesk in 1995, and I'll give a little bit of a rundown of some of my jobs in the company. So I've been there 25 years. Last week, 2 weeks ago, which was honestly a big surprise to me. I never expected to be at the same company, and the first large company I've worked for as well for that long. But you know, for various reasons, it's proven to be a really great place for me to get what I want out of my career. So there I am, 25 years later. But I won't go into too many details about what I've done. I mean, I will talk about. I joined Autodesk directly from university. So I did a computer science degree. It was actually a master's, but it was a 4-year program, and the third year was spent studying computer science in Paris for a year. So that was how I ended up. Well, I mean, the reason I joined Autodesk is because I'd already done some work for some Autodesk users and partners when I was still doing my studies. So I was familiar with AutoCAD. And I'd, even been asked to give some training to people using some, third-party AutoCAD software. So I had a little bit of familiarity with the space generally. And it turned out that Autodesk was looking for people who wanted to go out and talk to people about our technology. And it seemed like a really good fit for me. So I went for it, and I was lucky and got to join.
So that basically means that it was not out of some kind of a construction industry background that you ended up at Autodesk. It was rather the IT science background, in fact.
That's right. At the time, Autodesk was just kind of going through its major verticalization efforts. So prior to that, it had AutoCAD as a very horizontal piece of software that can be used in architecture, but can be used in lots of different ways as well. It's not very architecture specific or AEC specific. Now, around the early to mid 90s, there was a big push around verticalization, initially using AutoCAD as a platform, but later on using non-AutoCAD based products. So yes, I didn't come in with any real industry background in AEC at all. I still feel that it's a little bit lacking. I think for many of you on this call, or all of you on this call, probably you have more background in the industry, in the sense of understanding formally how things work. So I only see your position as being an advantage, and honestly, software skills are relatively easy to pick up. So I think you're all probably better placed to start your careers than I was moving in this particular direction. But I've muddled through, and I've managed, so I can't complain.
So to put your perspective in context for all of you guys who is from the industry in this meeting, we are here from the BIMCafe, the Architectural Technology and Construction Management Studies. So that's why Kean is referring to our backgrounds with AEC programming and tools from Autodesk and other suppliers. But it's definitely exciting, Kean, to have you here today. At the moment, we are trying to adjust to the new transition into a more digitized AC industry, and of course also educational system. So we are trying to also cooperate more with the IT guys and the people actually understanding how to program and make a development also with web and tools, programs, codes, and so on. So I say, Kean, thank you for joining us. Let's just jump right to it. I know that you have some quite exciting things going on with digital twin and Project Dasher.
Well, yes, I mean, I think it's exciting, but I guess that remains to be seen. We'll see what you all think once you've seen some of it. So let me go ahead. I'll start sharing my. Let's share my desktop. Hopefully that comes across okay, and then I'll go full screen. Perfect. So getting started. My name is Kean, so like Kia, but with an N on the end, so that's easy to remember. I suppose my official title at the moment is either software architect or platform architect and evangelist. I guess it depends which system inside Autodesk you look at. But software architecture, of course, is different from traditional architecture. I'm focused on making sure that the tools that we're developing sort of adhere to certain standards, and there are similarities perhaps to traditional architecture, but my role is a little bit different from a software development role. Now my Twitter handle is there at KeanW, so you can feel free to follow me on Twitter or connect via LinkedIn. I share quite a bit of content through both of those channels. So you'll see more or less the same thing on both. Though I may tweet a little bit more than I share on LinkedIn. It really depends on the day. And then my email address is there as well, of course. So feel free to reach out and to stay in touch. I will.
Also for the students, Kia, it's normally I'm trying to push that all of the students of Kia in these talks, they should so definitely reach out to you, our guest, to get the latest knowledge. And I hope it's fine that I'm going to share your LinkedIn account and so on. You already did it with your email and such. Is it okay?
Yes, absolutely. So please do get in touch.
I'll post it in the chat then.
Yeah, one thing I will say up front is that, please don't expect me to be able to provide technical support on things, because that's something that I really, unfortunately, don't have time to do. And apart from anything else, I'm probably not the right person to help you with your question. But in general, do reach out, get connected and stay in touch. I'll be very happy to hear from you.
I posted in the chat, guys.
Okay, fantastic. So a little bit more about me, looking at some numbers. This is one of the reasons I didn't go into it in too much detail just earlier. But as I said, I joined Autodesk in 1995, and the first 17 years with the company was with our developer network team. So I had a variety of roles. Some of them were technical, some of them were management related. In the end, by about 2012, I kind of made the decision that it was time for me to try something else within the company. So I had the chance from moving from, at that time, a senior manager role within ADN to a senior technical role inside the AutoCAD engineering organization as a software architect. So I switched across to the AutoCAD team, and I essentially became responsible for the technical direction of a number of the AutoCAD-based verticals. So AutoCAD architecture, MEP, mechanical. I don't think electrical was on the list, but anyway, there's a number of them that I had responsibility for at the time. So I stayed there for nearly 5 years, and then in early 2016, I moved across into Autodesk Research, which is where I've been since. And I'll obviously talk more about what I've done inside research. But before that, I've also, just to point out, I've been lucky in the sense I've had the opportunity to work in many different countries as well for Autodesk. So you could probably tell from my accent that I'm originally from the UK. So I started working in our office in Guildford back in the day, and worked there until '98 when I first moved to Switzerland. Then I think in 2000, that was my first management job when I went to the US to the North Bay in the San Francisco Bay Area to manage my first team. So it was a team of developer consultants, or who were part of the developer network team. And I did that for 3 years, and then moved across for 2 years to India, where I managed an equivalent team for Asia Pacific. And it was in 2006 that I moved back to Switzerland, this time as a senior manager with a worldwide team. Now, it was actually when I moved back to Switzerland that I started my blog. And one of the reasons was at this time I was becoming a senior manager. I was gradually getting further and further away from both the technology and our customers. So it seemed to make sense to me to find a way to stay connected with both those things or people. So I started the blog. It was initially focused on developing software with AutoCAD for AutoCAD using various APIs, but particularly .NET. It turned out to be quite a popular topic. So there's a lot of people followed me back in the day related to that. As my career has progressed, I've clearly ended up getting involved in different things, and particularly since I joined research, I've spoken a lot more or blogged a lot more about my experience of developing software with Forge and in general, what my life is about these days. So if you go to keanw.com, this is the content. This is where you'll see the content that gets shared out through Twitter or LinkedIn.
And
so as you can see,
already kind of made a post on this event. In fact, are you posting all sorts of events in here also? And are you actually also trying to make it obvious for people where to find the latest knowledge about development?
Yes. So it really is. My intention is to inspire people to. It's first of all to help people solve problems, particularly when working with Autodesk technology, of course, but also to inspire them to consider possibilities for using our technology in interesting ways. So while I'm using our technology to solve a particular category of problem, I think that there's I know that of course there are lots more uses possible for the similar techniques. So I try and share as much as I can there. And if we scroll back, there's some topics that we'll cover in more detail today. So here, just for some fun, this is as I said 2 weeks ago when I joined, when I did my 25-year anniversary post. So this was me. This was me when I joined Autodesk, or just a bit before I joined Autodesk. So actually, honestly, Asker, I don't look very different from you. I used to tie my hair back as well in a ponytail. So I don't want to scare you, but fast forward 25 years.
Detail, huh?
Yes, exactly. So anyway, you may be luckier than I was, but anyway, let's see in 25 years' time. But if you can scroll down and you can see some pictures from when I first joined. This is one of my early PowerPoint presentations at Autodesk as well. This is me on a trip that I made to India quite early on. Anyway, there's a bunch of fun stuff inside the blog that I'd encourage you to go and check out when you have some time. But most of it is technically related. I try not to blog too much personal stuff.
But how important is this blogging even for the development of your career and of your self-consciousness about your position and justification of that position in the industry? Does it give you some reflection back that you're able to contribute to the industry with new knowledge like this in a blog?
I've for my own career, I've found it to be completely invaluable to have, or invaluable is one of those weird words in English, which means highly valuable. It's been really, really helpful to have worked on this blog. It's been a passion for me in terms of engaging with the community. It does take a lot of effort. That's the one thing I was in a sense of privileged position when I started the blog, because there was a great deal of pent up demand for the information that I was publishing. So it very quickly became quite popular, but it can be very hard to get traction with social media, to sort of build your profile and to get people to connect and to pay attention. I mean, also these days, I don't know if I would start a blog under my own domain, etc. if I was doing it again. There's lots of ways to get information out there. LinkedIn itself is a very good platform for sharing information these days. But I will say that engaging through social media is a really good way to build your personal profile. It's one of those things where for me it was about helping get information to people, so helping the community, which helped Autodesk, of course, as well, and helped me personally. So it was really like a win-win-win in that sense, and finding an opportunity to do something like this can be really beneficial. Yeah, so for me, absolutely. I think it was the blog that I started in 2006 that enabled me to then move across into other roles inside Autodesk, because I'm not sure I'd have had the technical credibility, having spent a decade or more as a manager prior to that, to necessarily go into a senior technical role, unless people had just knew that I was engaged technically and interested in these areas. Mm-hmm. Yeah. Okay. So yes, I at least for me, I can't say whether it's for everybody, but for me personally, it's been a great journey, and the blog has really helped facilitate that.
Mm-hmm. Okay. So would you actually encourage people to sort of also build their own presence, knowledge spreading wise on the internet, while we are getting more and more digitized? And have to collaborate across disciplines and companies more and more. Is that a great way to share new knowledge?
I think so, but I think that there's also there are different roles that you can kind of play in terms of social media generally. Like, a lot of people share information that are created by other people. So I tend to focus a little bit more on creation of content rather than sharing, but there's a lot of value to be had from sharing material as well. So there's different approaches you can have to being to engaging with social media. Of course, there are people who don't share or create anything and are just happy to consume, which is absolutely fine. And I think I've seen this as I've seen images where it talks about a pyramid of different layers within it, but it's certainly, I think, a very valuable way to help create awareness about the things that you're interested in, and especially if you're working on particular technology problems, to help solve these problems in a more broad sense, not just for you personally, but for the wider industry as well. So yeah, I would say it's a good thing. Again, each to their own. It was a good thing for me. I will say that, and I would imagine for at least a number of people listening that engaging through social media is going to prove valuable as well.
Cool.
All right. So I think, is it good to pause for questions about sort of my background now, or should we just come back to that during the chat?
I guess it makes sense that we just skip that for now and get back to it in the Q&A session. And the guys, participators, please just post your questions in the chat function as we go. And I will try to mediate it directly to Kean Walmsley doing the talk. So just post if you have anything also regarding the subjects he's going to speak with us about now. Post it, please.
Okay, perfect. So I'm going to talk to you. I've got the main topic of this session is to talk about digital twins, and with specifically a project that I've worked on related to developing a digital twin using the Forge platform inside Autodesk. Now, I only have a few slides with any text on at all. Most of the slides are either images or videos, and then we'll spend quite a lot of time looking at a demo. So this is not going to be death by PowerPoint, that much I can promise. So, and this is an initial kind of definition of a digital twin. Now, digital twins can mean different things to different people. For some people, and for some use cases, a digital twin can be something as simple as a spreadsheet. I mean, it really is that straightforward. But in our case at Autodesk, we tend to think of digital twins as being kind of based around this idea of some sort of virtual model, a 3D model. Again, we tend to look at things very much from a 3D centric view of the world. So we'd have a 3D model, whether it's based on some BIM data or some other 3D modeling data at the core. Oops. And then around that, we have a layer which is focused on some sort of system model, how that 3D model fits into a broader picture, and simulation. How can you predict forwards and think about, how this model is going to respond to certain situations. Then, of course, we have an additional layer, and this is where I tend to spend most of my time, is how to bring IoT data and data from real-world sensors and control systems into the 3D environment and find interesting ways to display that data, essentially to contextualize the data in 3D. So these digital twins very often are used for monitoring, diagnostics, prognostics, optimization. My particular focus tends to be on historical data, so I tend to help build systems that are focused on going back in time and analyzing how an object or a building has performed historically. There are other people who tend to focus more on real-time scenarios where you have dashboards and you're thinking about various actions being triggered when events happen that are interesting to you. And then, of course, there's another category of scenario where you're really focused on what's going to happen in the future. How will this building perform in 10 years' time based on a certain increase or decrease, as we're seeing at the moment, of occupancy. So that's the kind of thing that tends to be integrated in some way into a digital twin. So while I'm focused on historical at the moment, we have integrated sort of more real-time capabilities, and we're certainly looking at integrating more simulation capabilities into our system as well over time. Yeah, so as we're really talking about ideally a living digital simulation of a real-world object, a digital twin should be able to learn from real data and have continuous improvement over time. Okay, and then of course you can integrate, and increasingly we're integrating technologies such as model predictive control or machine learning or what have you into this environment in order to better predict the future.
And these data that is being adapted through time, is it also meant to be read like cross platform wise, so that you're able to read the same data from independently which platform you're basically using, such as Revit versus ArchiCAD versus something third?
Yeah, so that's I would say that's the goal to some degree. I mean, particularly in the sense of Project Dasher, we're using the Forge platform, which kind of gives us access to a whole load of different modeling formats. So, whether the model has come in from ArchiCAD via IFC or perhaps, or we've done, for some projects, we've imported data from Rhino, for example. The 3D data comes in through Forge, so we don't really care too much about the source of the 3D model, and then we integrate the data. And of course, it's ultimately a web-based application, so you can use it across devices, across platforms, across browsers, etc. So from our perspective, it is a relatively but I'll talk a little bit more about what Dasher is and that in that context, because it isn't a fully fledged digital twin either. It's got a fairly specific scope in that sense. So this is a slightly broader picture of what we are talking about, at least. And when I say at Autodesk, I shouldn't even really say that, because there are other teams that are now focused on exploring digital twins within the company, whether inside research or elsewhere. So I don't think this is necessarily representative of everybody's view of digital twins within the company, but it's certainly how our team has looked at this. And so on the one hand, and we'll go from the left to the right, we have this idea once again of I've lost my cursor, but never mind, I don't need it. So we have the geometric representation of metadata coming, in our case, through BIM, from Revit. Then we have control data, control behavior. Now, in the case of Dasher, we've deliberately avoided getting into the place where we're using it to control systems. So we're really using it as a diagnostic tool and a tool to explore data, but we're not intending it to be an operational tool where people can then make changes into their building management system and change the values of thermostats, etc. Now, it's technically feasible to do. It isn't necessarily challenging to make the control happen. What is more challenging relates to making sure it's a secure system and you don't have anybody coming in and ultimately making changes to your building without you necessarily wanting to. So that's why we've tended not to focus on that as an active research area, because we're more focused on the exploration of data. So that data is coming in from the BMS, so building management system, and IoT sensors that are deployed inside your building. Now, increasingly, we're going to also integrate simulations, but we don't have them integrated today. So we do have people in the team who are, in the team I work in, who are focused on simulation activities. But at the moment, those are separate and they're not necessarily connected into the digital twin. But we do have these capabilities that revolve around displaying data, whether it's showing graphs of data, whether it's showing surface shading, etc. And so for us, when we talk about digital twin, we talk about Project Dasher as really a systems debugger or a building debugger. The idea is that you want to go in and find out what's going wrong with the operation of your building in order to make changes.
One quick question for that, Kean. We have both people from first semester, third semester, fourth, and seventh. Some graduates are also with us today. Let's take the eyes from the first semester student. Will some students evolve into becoming people that basically sits and monitors digital twins of houses and systems all day long, or will it become a massive part of their daily life in as an engineer assistant or something like it on an office?
So I think it's possible, but I think it's more likely that over time, the person who's involved in that sort of role is more like, I think a lot of this will get automated in terms of the management of operations in general. There will always be cases where your system is not trained or capable of dealing with scenarios. So I think a tool like Dasher is probably going to help people understand the different scenarios that are existing in their code. Sorry, not in their code, in the operation of the facility. Then over time, you'll be able to train your AI or neural network or what have you to identify the patterns that are in these scenarios and take action accordingly. I think that there will always be cases where you don't really understand, or the system can't really deal with anomalous behavior. So it's going to take somebody to come in, some physical person to come in and make sense of it and then help train the system in order to deal with that in the future. I think that's probably a more likely scenario than having somebody sitting behind a tool like Dasher as a or any digital twin as an operator of that twin. I think it's But again, it depends how far forward you look.
The picture and to sort of scope the context for everybody, right? But it sounds interesting. Please continue, Ken.
Okay, no problem. So we started researching this area in late 2009, so quite a long time. I mean, I don't know if we talked about the Internet of Things or digital twins back then. I mean, for us, it was really about building a building debugger, debugging the built environment. So this is the first iteration or incarnation of Dasher, excuse me, which was a desktop product. We built this tool based on various internal Autodesk tool technologies, but as a desktop tool, of course, it was complicated to deploy and to maintain. So there's still some capabilities in the original Dasher that we haven't got around to sort of implementing inside the web-based version. But it was certainly for us a great way to explore the early possibilities around contextualizing 3D data and how much easier it is for people to absorb data when it's presented in this way rather than having it locked away inside database tables and inside graphs. So for us, this was quite interesting as a capability to allow people to do this kind of exploration in a 3D context. So that was that was the desktop version. This is a project or this is some data that came from a project that we did with NASA in California. So this was the Ames Research Center, which is their sustainability base in California. And we went in and helped wire up a whole load of sensors across the first and second floors of their building. This is a view of the second floor showing a time period where we're sort of visualizing temperature data across this second floor. And so one of the reasons you can probably see in the bottom right hand corner, this, just use your imagination. There is a NASA logo under there, but for copyright reasons, we tend not to use it on public presentations.
All right.
So there, when we first showed this visualization when we showed the system and started to look into it, and with the NASA scientists, they quite quickly identified a few areas that stood out as being interesting. The first one was this central zone, which is cooler than the rest of the building, and they said, "Oh, well, that's completely natural because this is where we store our servers. This is our data centers essentially. So it is normal that it's quite a bit cooler." But then there's this one room in this corner of the building that they were also surprised that they thought about this, and they said, "Well, why is that room so different from the rest of the floor?" And then somebody in the room said, "Oh, well, that's where we're running our glazing study. So we've put some film, ultraviolet film or film on the windows to protect from ultraviolet. So it's reducing the amount of heat that's being generated inside the room from sunlight." But they hadn't crunched the numbers yet. This was something that they pulled out of the data because they were able to see it visually. But it's not something that they had sort of had the time to necessarily go and process from formally as part of their research. So this was immediately an interesting aha moment for us. The fact that they were quite quickly, they had they were able to go in and identify this situation.
So you were basically saying by visually laying out the data of a building like this and putting it in over a time span where you can go back and forth and sort of see the development of certain attributes, you can actually find out find new angles on the materials of your building, on the design of your building that you didn't expect to see when you brought it up.
Yeah, and even at a more silly level, like sometimes when buildings are put in place, things aren't wired right. You have, for one building that we did, we quite quickly realized when looking at the data and the way that the thermostats were connected with the heating system, that the thermostats were controlling a completely different area of the building than the one that people were expecting. So for that particular pilot, they were able to go in and make sense of that quite quickly, given the graphical data. But it's again the contextualization that was helpful. They could have found out the same thing by going in and monitoring the low level data inside some sort of spreadsheet view or a graphical view. But having it like this in 3D does make it much more consumable, at least some in our experience.
And easier to communicate to a way wider audience, right? That's
also true. So there is a certain appeal to this kind of 3D capability for people who are higher up in the organization. Perhaps the people with an operational focus, maybe you may not necessarily find it as valuable or see the value in different areas. So it's important to try and drill into the needs of different communities, because of course a lot of managers will see this and say, "Oh, this is great. I have the information I want in a graphical form. It's easier to consume." But we need to also cater to the people who are using these tools hands-on and want to get there quickly. So it's an interesting balance.
Data-wise, is there some outer limitations? Would I be able to track the carbon emission of my concrete over a span of 50 years, for example?
So I think there's a lot of, and we'll talk a little bit more about this later, because I think this whole area of, material passports and the circular economy, and it's an extremely important and valuable area. And we've started to have discussions with some parties on how that kind of information would be integrated. But I think digital twins in the future will have to take care of this kind of information. Now, it may not necessarily relate to IoT and the integration of that data, but in terms of the model itself and having that evolve and having that rich capability built into the model, so you can really understand, when the building gets dismantled, what you have and what you can, start to do with the things that are there. But I'll get onto that a bit later. I should probably move to the next slide because we still have quite a bit to go through. This is an interesting project we did with Schneider Electric in Grenoble in the south of France. So they had a building where they'd installed a new type of sensor that they had available, which gave essentially positional information about occupants. So here we can see these like purple Playmobil people who are moving around. They represent data that we captured on how people were occupying a space. And here what we've noticed is the CO2 levels, which you see as a heat map, have spiked in a particular room. So we're drilling into the data, zooming, scrubbing back a little bit in time, slowing down the data and looking at it at a finer granularity, so that we really start to make sense of what has happened. In this case, it's just because there's too many people in this small space. But then we can take a look at a specific CO2 sensor in that space and then zoom out on the data and say, well, how often does this type of situation occur? Is this something that we can manage in a different way? So this is an interesting example, and it was one of the early examples that we had of correlating data. So not just taking the CO2 data, but combining it with occupancy data to get more value out of the system overall. So this idea of correlation has become something that's extremely important for Dasher. Is how can we find ways to present data in coming from different places together in a way where you can really start to have an overall view of what's happening. The next project that we embarked on was a slightly different one. So this was a more infrastructure related project. So it was less about a building, even though it was in a building. So this is our Pier 9 office in San Francisco, where we have a pedestrian walkway going between two parts of the building. Now and I'll explain why in another slide or two, but we needed to understand whether we applying different types of sensors on a bridge, whether it's accelerometers or strain gauges, would provide us with interesting insights in terms of the utilization of this smart infrastructure, if you like. So here we have kind of a first-person view of the bridge, where we were able to integrate CCTV footage of from the security cameras that were set up in the office, either end of the bridge, and where we can so here we're correlating movement of a security guard across the bridge while he's checking his phone in the middle of the night with, what do we get, or early morning, what are we seeing in terms of the strain on the bridge. So we're starting to correlate.
Could I actually tell my AI to monitor whether the security guard was standing still on a bridge and checking his iPhone, and then get the AI to monitor that and send the report further to the operation?
Yeah, so that's a good question, and but it's a very scary question, right? Because when you start to get into the point where you're dealing with, but it's a very timely question, because it's exactly why we shifted our thinking around this to make sure that we were respecting privacy. Because of course, if you give anybody access to this system and they can pull up CCTV footage, there is a serious sort of potential issue there in terms of privacy. So we started to explore the possibility of blurring, in this case we have blurred out faces, but just extracting the information that we need from the video footage and then throw away the video footage itself. So here we're able to, we did explorations around pulling out skeleton data from wide scale video footage, and then ultimately being able to take that data and reintegrate it into a 3D environment and show. So this could be the security guard walking across the bridge, right? That's the idea. So rather than having video footage that has personally identifiable information in it, which has issues related to GDPR, et cetera, et cetera. In this case, we're extracting something that is highly anonymous. Now, the reason that we started this project at all was because of a project that we engaged on with a Dutch startup called MX3D, and this is the world's first robotically 3D printed steel bridge. It's probably the world's first 3D printed steel bridge, but it's not the world's first 3D printed bridge, because there are also some concrete bridges out there already. But the vision behind this was to have a couple of welding robots, building their way across a canal in Amsterdam. Now, in reality, of course, this was never really going to play out in this way, because you can't just have welding robots exposed to the public because of the brightness of the welding, the arc welding light, etc., whatever you call it. But so ultimately, the vision was more to have the bridge printed or built off-site in a factory or in a warehouse. So this is fairly close to what happened. In reality, it wasn't 4 robots doing it. It was done in a much more piecemeal way, I would say, with a number of sections of the bridge being welded together. But it certainly proved out the potential for this. The potential for this technique to be able to build something. Now, one of the reasons why Autodesk got involved was because as the first of its kind, and there's no real knowledge in the industry or in anywhere around how this, which is ultimately a new building material, will react. When it's used in midsummer. Used in midwinter, has 100 people walking across the bridge. So this bridge is going to be installed across a canal in the red light district of Amsterdam. So not only are you going to have lots of people walking across the bridge and probably jumping up and down on it like we did here, just to see whether it moves. And you can see there's a little bit of displacement there, maybe a couple of centimeters. But you also got to think about people's privacy, because people in the red light district in Amsterdam obviously very often will want to be, have privacy related to what they're up to.
Okay.
So it was that clearly it was very important for us to respect these things. But ultimately, our aim was to build this sensor network into the bridge in order to understand how, as a piece of smart infrastructure, it was going to behave in different scenarios, and then eventually be able to predict how things might not work.
It looks very accurate, and also as we're speaking about the ethical standpoint is super important. Do you guys at Project Dasher actually have a department only taking care of that side of the development? But I can guess that it's actually accelerating a lot and going very fast with these techniques.
Yeah, so honestly, we don't have a big team focused on Dasher. There's a number of people in research that get pulled in depending on what we're doing. Okay. Ultimately, so this was for the MX3D, this is a project that we did in combination with a number of other partners around the hardware, of course, around the design, and we weren't at all involved in the production of the bridge. But here you can see, this is at Dutch Design Week where we did our first sort of tests of whether we could pull out skeleton data. So here you can see that there's some, we're matching that up to the video footage that we were just including in there to see whether it was reasonably accurate. With the goal, of course, ultimately, and we did see a quick flash of this before, where we could take a heat map of some sort of stress data. In this case, it's acceleration data, which doesn't really make sense to be displayed in this way. But we're essentially mapping stress strain data from the bridge along with the usage of the bridge and get a sense of the people who was walking across it, where they were at the time, so we can correlate once again these two data streams in a meaningful way. So this was the MX3D project. I do have a quick video, but I have a feeling, because I'm using Teams on the Mac, that you won't hear any audio. So
let's see how it goes.
Can you hear me?
No, it's you're right.
All right. So what I'll do is I'll turn the volume down a bit so it's not disturbing me. But basically, I'll explain a bit what's happening, and it's probably just as well you can't hear the video, though you can hear it. You can watch it on YouTube separately, because I was extremely excited when I was filming this video, because this was us being able to display real-time skeleton data. So we had the computer vision system set up, and my colleague Mike I'm encouraging him to walk across the bridge while we're checking the results on my computer. And so essentially he's going to, as you know, gradually we got more and more people walking across the bridge, and we can see in real time the skeleton data. So that's Mike climbing up and walking across.
Yeah.
And there's a few other people ended up joining to go ahead and you know, prove that we could visualize multiple skeletons of people as they walk across the bridge at the same time. So I'm getting more and more people up there.
At this stage,
so this was, sorry, I'm just trying to, let me shut the audio off on this side so I can, all right. Actually, I need to turn it up so I can hear you. Sorry, yeah. That's the problem. All right, let me pause the video now. All right.
It's just a quick question, not to interrupt you too much.
Sure.
I was just wondering about the latency of the data coming in from the sensors on the bridge to your working station.
Yeah, so that's an excellent question, because if we'd just relied on the database itself, then you'd have the latency of the capture of the data, the processing of the data, sending it to the database, which probably is somewhere in the US, or moving forward it won't be for GDPR reasons, etc. But for this particular project, we had the actually no, we had local servers. But anyway, there's going to be some latency with the round tripping of the data. So what we implemented was a way to send the data more directly from the processing server, which is crunching the video footage and extract, and it would send that data via WebSockets, which is a communication technology, directly to the web browser, so that we didn't have to go via the database at all.
All right.
Oh, I think I probably got dropped for a second there. You can see me?
Hear you. You have a little bit of latency on your connection, Kean. I don't know if there was some interference, but it seems like you're online with us again now.
Okay, let's keep my fingers crossed.
But I just need to see there is one participant with their mic not muted. Please make sure that your microphones is muted, guys. Okay, and please continue, Kean. Everything's good.
Okay, great. All right, thank you. So the next project, and this is one that we'll talk about a bit more, is this project with EMPA and ETH, was for the Nest building in Zurich, or in Dubendorf, which is on the EMPA campus on the outskirts of Zurich, which is a really interesting building. So this is essentially a showcase for digital fabrication techniques moving into the next 50 years, I imagine, where they've got they're focused on being zero emissions. We're focused on taking I mean, this place is crazy. They take excess energy that's created by the building. They convert it into hydrogen that is then used to fill hydrogen-based vehicles that come up and can just fill up at the filling station there. They recycle the waste from the toilets. So they invented a special toilet where the urine goes through one pipe and separated from the other materials, in order for that to be processed to create fertilizer to go onto fields, etc. So they're really focused on sustainability. This particular, oops, sorry, I didn't mean to go forward there. This particular unit, and I don't know if I still can't see my cursor, but the middle unit there, which has got all the colourful sort of boundary, that's the urban mining and recycling unit, and that everything inside that unit has a material passport. It's almost all via recycled materials. They have a gorgeous old brass doorknob from an old bank that's been essentially recycled. But they have all this circular economy information about the materials in order to encourage the reuse once it's decommissioned eventually. So this building itself, we were lucky enough to be able to collaborate with the Nest people on creating a demo based on this this fantastic building. It had upwards of 2,000, or has upwards of 2,000 sensors in the building. So we took a subset of those and brought the data across into the Dasher backend system. And if you go across to dasher360.com, then and you click on demo, then you'll see this exact model come up. And one thing I'll say is if you click on, well, let's see if I can get my cursor back. Oops, no, I can't. Anyway, my cursor just totally disappeared at this stage for some reason. If you click on the film strip icon, which is at the bottom of the left-hand toolbar, then you'll see this sort of automated demo. And I think at this stage, it's probably a good time to flip across and to show you a demo if I can. I want to try, there we go, escape, perfect. So I'll go across to my browser and then we can already load this up. So you'll see that this has got a different URL, just because I'm showing you a version which actually has more capability than the one that's currently live on dasher360.com.
Okay.
So, but if you go to dasher360.com, you'll see this, the same thing. So I'm going to click on demo. We're going to load up the the Nest model automatically, and then I'll step through some capabilities with Dasher to give you a sense of how it works. Not so much because I want to sell this to you. This is really a research project that I've been working on, but to give you a sense of the kind of possibilities you have building a system like this. I mean, we used Forge to do all the visualization of this, along with some other libraries that we integrated in to the Forge viewer. But ultimately, there isn't anything that we've done that couldn't be replicated by somebody with enough patience, I would say. So here at the bottom, we have the overall sort of toolbar of the Forge viewer standard toolbar. And so one interesting aspect, we can kind of click on different objects and bring up their properties. Here, this is an interesting capability that comes for standard with the Forge viewer. And here, if we click on this clustering view, what's going to happen? It's going to take a little bit of time to think this through, but then it's going to separate all the contents of this building into their various categories. So you can see, these are there are the pipes there, the ceilings, you have all the different objects we can span around. So this is, again, thinking about the richness of the data and the model itself and the potential capabilities that you might have related to understanding circularity of materials and reuse. So there you've got all the floors. Anyway, so this was just in a sense, a little bit of a fun capability that we could implement inside Dasher, just because it was there automatically, really inside the Forge viewer. But the main capabilities of Dasher are all inside this toolbar on the left-hand side. So, and as I mentioned, if you click on kiosk mode, it's just going to run through all these various, or a number of the capabilities inside Dasher that I'll do normally. So let's take a look at some of these features myself manually. So if I click on the sensors button, what it's going to do is to bring up the sensor locations. It just has to refresh again because of something I did earlier. So it's going to bring up the locations of the various sensors and visualize them in 3D. So normally this it doesn't need to refresh to do this, but it's because there was a pending refresh from what I was doing before. So here you can see the various sensor locations inside the 3D model. And as we're able to, we can hover over them, we can bring up the data associated with a particular sensor. And once again, we can kind of zoom out, and very quickly we can see like months, if not years of data at the same time. But at the same time, as we zoom in, it very quickly resolves down to different levels of detail. And this is a key capability inside Dasher. It gives us this ability to explore data at multiple levels of detail, averaging out the data as we do that. Because ultimately, if you want to pull in a year's worth of data from an IoT system, you don't want to query the raw data. You need to have some ability to have a summary of that data at different levels.
A quick question to that, Kean. Would I be able to customize my data board so I'm able to show different kinds of data? It could be temperature, amounts of people inside of the building, light hours, whatever, at the same dashboard. Would I be able to create that?
Yeah, to some degree. I mean, we do have a dashboard capability that you can customize with different, with different sensors. So here, for example, I'm not logged in, but if I was logged in, I could go to the sensor list, which is, as you see, as I hover over the sensors, you see the individual sensors are highlighted, and it's kind of bi-directional. As you hover over sensors in the 3D model, they get highlighted in the sensor list, so you can get more information about them. So we can if I was logged in, I'd be able to hit plus on some of these and add them into this dashboard here. But I would like to sort of emphasize, it's not really intended to be a dashboarding operational tool that's used for live data. It's really about exploration of the data. So people do often ask the question because they're interested in the relative capabilities for operational use. But our view with Dasher has always been from the angle of sustainability and this desire to enable people to improve the efficiency of the built environment in order to help impact the amount of, or the damage we do to the climate ultimately.
So it's rather history than
yes, it's more about history than it is about understanding or being alerted when things happen in a certain way. So that's and then the same with the dashboard. If we can go through and kind of look at different views of the building that we've decided to capture and add in here. Whether external or internal, so you can go and check these out and take a look at how these all work. We have sort of additional capabilities related to visualization of different parts of the building as well. So let's say we just want to focus in on the data from the third floor of the building. So in this case, we kind of we've got this thumbnail view in the top here, and I'm just waiting for us to finish rendering because I can see normally there should be some shadows there, otherwise it's not going to work properly. So it's still finishing up, and then if I click on the floor selection, then I can hover down through the different floors that there are in the building. So here we can kind of go through to, let's say, the first floor and take a look at the heat map data for this floor. So here we can turn off the textures on the floor and then turn on the surface shading for this particular floor. Now this is giving us a kind of a 3D view of the temperature at this moment in time. Oh, okay, I wasn't meaning to do that exactly. Let's see, there we go. So I was going to drag this across, and as we drag it, it should impact the visualization of the data that's shown. If we hit play on the timeline, let's speed it up a bit, then you'll see that the temperature data is changing as we go through this particular time period. Now this is interesting, but it doesn't give us much correlation. We can go in and sort of look at tooltips and sort of look at individual multiple sensors at the same time, so we can, and even pulling up individual sensors and seeing the data sort of cycling through. So it does give us this kind of capability to associate one graphical heat map in 3D with a bunch of with a bunch of different graph views on the data, if you like. But one of the things we've been focused on more recently was this idea of being able to not just have a 3D view of the data, but be able to correlate that with additional 2D views. Well, I'll enable that while we're at it. And then, so here we have this idea of 2D heat maps. So if we hit play again, you'll see the same animation is happening in the 3D view as in the 2D view at the same time. Now, of course, we can then go and sort of pull up additional views or additional data streams and have them visualized alongside. This is presence data, which is actually kind of interesting because this is telling us the occupancy in this particular zone at any one time. But because we're looking at a higher level of detail, and if we can go back out and say, well, let's take a look at, you know, the day by day data, and we play again, you'll see that the data changes a lot less frequently. But because it's averaged data, it doesn't really. It's all been averaged down to a very small number because on average there isn't anybody in these rooms. So what we can also do is say, well, let's take a look at the maximum data, and that will give us a very quick sense on a day-by-day basis whether the rooms were occupied. So you can see as we pause there kind of during the weekend, we can see that there, sure enough, during the weekend, this particular area was not occupied at all because we've got these whole periods where during that whole day the maximum value is essentially 0.
But they had a party in the right corner, lower corner, or what? Sorry,
say that again.
They had a party or a staff meeting.
Yeah, well, quite possibly. This is an interesting room because it's surrounded by glass and it's got a load of plants in it. So I have a feeling if anybody was coming to hang out during the weekend, this would be the room that they'd come to. So that makes sense. It's also the hottest room in the building as well by quite some margin. But that's
would you be able to sort of input data around ventilation systems, for example? Now you just mentioned humidity and such. Could I input some ventilation data from a program like Revit or from another output that I decide? That
is a great question, and I'm just about to show that. So that's perfect. So I mean, one thing is that you can see. Well, so before I get to that, so once we've done this kind of initial view of floor by floor view of the data, so if we can see once again if we go to different floors, you can see that the visualizations are changing because these panels were intended to be for a particular floor, or generic. They'll display the data of whatever the floor is. We decided that we wanted to include this capability to pin particular heat maps for a particular floor. And this allows us to correlate data, once again, across multiple floors. So if we pin the CO2 and the temperature data for the first floor, and we can then go and take a look at the second floor, we have this opportunity to take a look at like temperature data for multiple floors of the building at the same time. Now, actually, we don't have sensors integrated for the second floor, so it's not that interesting. But it gives you this idea that we're able to correlate across floors as well as just for a single floor of the building, which was interesting. Beyond that, the next point was, well, that's great, but getting back to your point about the mechanical systems, now how do we integrate that data? So we went ahead and added the capability to parse the data coming for various layers inside the 3D model that have come from Revit that describe the mechanical systems of the building. So here, all being well, once this comes up, we should see a layer which once again is on a kind of a floor by floor basis that shows the mechanical subsystems for this particular building. So, okay, I've got to wait. I think I may have been too optimistic with my, there it is. Okay, so here we go. So if I then sort of go back and change this floor by floor view on the right hand side, you can see some of the floors actually in the basement in particular, there's a lot of mechanical geometry in there. But otherwise, floor by floor, you can get a sense for the mechanical systems, and you can start to sort of correlate the behavior of or the data that you're getting to what is happening from the building systems themselves, or start to understand what it is that may be giving you cause to, or why the data is behaving as it is. So here once again, of course, this works with all the heat maps, etc. So now that again was interesting. But now we've got this capability of being able to view across multiple floors. One of the things that we realized was we have a bit of a UX problem, and we can go in and kind of choose individual temperature sensors and then choose individual floors. But we started to think a little bit more about how we might be able to show that differently. So in this case, we implemented, and this was really just in the last week. So you're really probably the first people outside of my team who have seen this.
We love to get the newest knowledge, Kean, so that's awesome.
Yes, yeah. So you're seeing this, but this was a different idea in the sense we thought, well, how about we take each of the sensor types and each of the levels, and then just do a combination so that you get them all kind of split up like this. Here, once again, if we kind of toggle off the layers, then it should update the view on both sides. You know, if we choose that we don't want to have the data in there. But here, you know, we can really sort of zoom in. If there's a particular floor that we're interested in, we can double click it and it'll come up. It'll be displayed. Yeah, so there's a little bit of a, I've got to move that across so that we can still see it. And individually, if we then double click on each of these panels, it's going to show that inside the 3D view. So there's kind of an interesting hierarchy in terms of the display of the data, which I think is interesting.
Another interesting view would be, now you're talking about the displaying of the data. What about the storing of such data? How are you keeping it on the hard drive? Are you just having the casual files and log files like that, or is it in a blockchain, or how do you store it?
Oh, you mean the sensor data itself?
Exactly. Yes.
Yeah. So we have that stored in a back-end system where it's a time series database essentially. So all of the data is stored in a database, but when we're visualizing it for surface shading, we cache it locally inside the browser cache. So all, you know, we bring the data across in order to not doing kind of repeated requests for the data. But no, so some of this data is really big. You know, we've had to deal with, you know, in a typical building, you might be changing or storing the value every 5 minutes or 15 minutes for temperature. It's not really that frequent. But when you're looking at a bridge where you're looking at strain data or accelerometer data, you may be capturing 100 hertz, you know, 100 data points per second. So that is quite a large capacity system that you need to implement there. So a lot of the work for Dasher over the years has been on the back end in order to make that work. Now, having said that, you know, these days Amazon and you know, via AWS and Microsoft via Azure, they have, you know, time series offerings, as well as, you know, other people such as GE with Predix. So there's a lot of possibilities around time series backend databases out there. Now we're still using our internal one because it gives us these levels of detail. I talked about a little bit about that earlier as we zoomed in on the data in a similar kind of way to Google Maps, where you're able to, well, those ones aren't very interesting, but let's take this data and we can kind of, you know, zoom in and get different levels of detail. That's also a little more boring than I expected. This one, there we go. So, as you know, a bit like when you zoom in on a Google map, you see the different levels of detail essentially resolve as you get closer or you get further out. This is the same thing that's happening with this. So we have the level of details in these graphs. We also have the levels of details in this kind of surface shading pull down. So all of these are enabled by our backend system, and it would take quite some time for us to implement something similar on competitive systems or systems that are available on the market from other people. So yes, it's all stored in a time series database, which is extremely valuable. And then ultimately over time, that data is going to be increasingly, you know, processed using machine learning in order to derive insights from the data. So that's something that I think we're going to see more and more of over time.
Again, a quick question. I guess that these tools are not only meant for single units or single buildings. You could actually monitor a whole city or a department of buildings, a campus on a school or something like it.
Right.
Is this a tool for private organizations or for countries? I have a funny question from Thomas Vogt
Okay.
in the chat. It's a bit of a political question, but
Okay.
is this actually China's dream? Is this something that some states would really want to get their hands into because it's so accurate and so deep into the detail?
So it is an interesting question. I mean, for sure, we've always seen the work that we're doing on Dasher as being ultimately at the building scale, the scale of individual buildings, but with a view to us going up to, well, first of all, going down to look at things at a finer scale, such as individual products within that that scope, but then taking a more portfolio-centric view, whether it's across multiple buildings in a campus or whether we're looking at a smart city, for example. So I think the combination of this type of granularity of data, the BIM data alongside GIS data, it could be extremely valuable, and we're certainly exploring that in a number of ways internally inside Autodesk Research. So I don't think it should be limited at all to thinking about it as a building centric view of the world. Now, as the more political question, could there be value? Well, would certain states see this as valuable? I know that certain states see, Singapore has got a massive investment in smart city infrastructure, as an example. So they're taking this very seriously. Now, yes, I mean, I think there are obviously concerns in the long run that people will have related to how technology gets applied, just as we're seeing in China with facial recognition technology, etc. We are doing our best to sort of deploy it responsibly, such as we've seen with the kind of anonymization of people. But again, that's also a question of the choices that are made by the people deploying technology, right? So there's always the potential for abuse, for sure. I was just going to show this one quite quickly because this is an office the headquarter, the new headquarter building for Kingspan in Ireland. Sorry, I just had a brain freeze for a second there. So here, I think I don't have to do that. I can go ahead and turn on surface shading once again, and with any luck, it'll cause my the visualization that I showed earlier around the types per layer to come up as well.
A quick question while it's loading.
Sure.
From Vijaya, I hope it was the right way of saying the name, Vijaya Venkata, asks if it's possible to implement a complete InfraWorks model in Dasher without losing any kind of information.
So that is a good question. We've explored the possibility of bringing InfraWorks data across into Dasher to provide context. So that is something that we've done. It wasn't, with some success, I would say, just to give a bit of, again, some contextual data related to the building itself. I think what's more likely and more viable for the moment is that that we are able to integrate sort of capabilities, Dasher-like capabilities, into a tool such as InfraWorks. So that's something that we're considering and we're exploring. But today it's not possible, realistically, unfortunately. It will become more so. So here is another. So once again, you can kind of see this view. Here we have some much more detailed MEP data where we have got multiple layers, which is very interesting. And you can kind of click on or double click on these to bring up additional data. And all that, once again, kind of is animated. It's quite interesting. Oh, this is actually a bad. Let me stop that. I have to change the time selection. For this particular model, it defaults to the current time where we don't necessarily have the roll-up data for that, because it takes a little while to process. So I have to move this back in time a day or a few days to get decent results. Hopefully that should work a little bit better there. Anyway, so you get a sense for how we're able to then do this correlation on the 2D versus 3D side of things. And, we're looking at data across multiple floors, and what we're trying to do to enable the ability to visualize this data, or to navigate through the various sort of levels that we have inside a building, with the levels versus the types. So that's kind of an update on what we've been doing inside Dasher lately. I'll be talking a little bit more about this at AU Autodesk University 2020, which I believe the registration for it has opened today, or will be opening in the next day or so. So that's a completely free event this year. So it's a great opportunity for more people to be able to attend it. So I'd encourage you to sign up. You can search for me. That I'll be giving a class that's looking a little bit more into the guts of Dasher and how we've done what we've done, and also talking a little bit more about the future as well, which is something I can only talk about today in a limited way, because we've got things that we'll talk about later.
Of course. Another thing that we could talk about then, Project Dasher. How do you engage with students? How do you make sure that students who find this interesting actually gets to play a small or larger role in the development of the new tools that is going to be a big part of the industry that they're going to get into at some point?
So today, I think the biggest opportunity, there isn't much of a near-term opportunity around kind of using Project Dasher, or really even working on the project itself, unless you manage to get an internship at Autodesk, which do happen and are possible. But I think the opportunities would be to use Forge to do similar things, whether in a more complete way like this, or in a smaller scale way, would be to take components that we've built for Dasher and I've blogged about and published, or we as Autodesk have published, that you can take those capabilities and build something similar that solves a particular problem that you see as being out there. I mean, I will say that so we have regular Forge accelerators where members of the academic community, people from industry, come together or work on projects at these events during the course of a week, and they get really close mentorship and support from people inside Autodesk in order to help them build out these tools. So it's called a Forge accelerator. I won't Google it right now, but maybe you can do that, Asker. But there's one coming up, I think, in 10 days' time, and it's online once again. So in recent memory, I think most of the really interesting projects that I've seen at these events, and maybe I have a little bit of bias, but a lot of them relate to using the Forge in this kind of way to build digital twins. And the same thing is true of the AEC hackathons that I believe you were involved in helping manage the last physical one in Copenhagen.
We actually had a team on the February live one,
right.
And a couple of students actually won the first prize.
Right.
That surely kickstarted a whole new wave of trying to engage with the industry. We realized that we could actually participate a lot more than we already did. And then we also had appearance at the online one. And surely in the future, we're going to do some hackathons at some point. Let's see.
Right,
maybe,
exactly. So
maybe even be invited, Kean, I guess.
Oh. So I tend to participate in some capacity. No, I rarely, unfortunately, more due to personal commitments than anything, have the time to sort of spend a full weekend doing doing hackathons, but I usually am involved in some capacity. Like I did a Dasher talk at the last AEC hackathon, and I hopefully will continue to do that in the future as well. But certainly, again, a number of the interesting projects there were also digital twin centric, using Forge and using similar techniques. So it's definitely a hot topic and one that's of interest to people. And I think that learning more about how these work will also be beneficial over time as we sort of make it easier for people to build these. Because at the moment, I mean, we've had to do kind of, we've had to break ground on a lot of these things over the last decade or so inside Autodesk Research. And I think that as we're sharing more and more of our techniques and how we've done things, it should become easier and easier for people to build their own systems that are tailored to particular use cases.
So in regards of that, do you feel like you have to sort of break the ice with this whole digital twin thing before the industry is ready to adapt in full scale? I have a good question from Gabby, who's asking, why is it taking so long for digital twin to become the norm or a norm?
So I don't know more broadly in the industry whether it's what it is that might be holding it up from that perspective. I can say from my own experience and perspective working on Dasher is that there have been things that have been more complicated than, we expected things to move a bit quicker in terms of, the commoditization of the hardware, of the infrastructure related to digital twins, the time series databases. We had to build a lot of this stuff ourselves. We've had to create routing software that runs on a Raspberry Pi and takes data from sensors and feeds it into our database. We've had to run cables, physical cables to sensors inside buildings when we're doing pilot projects. And clearly, from a company perspective, that isn't scalable to do that for every project. So realistically, I think right now, with these offerings that are coming from Amazon and Microsoft related to digital twin infrastructure, I think that this is a really, really interesting opportunity. I think things are suddenly clicking into place a little bit, and this kind of commoditization wave is going to lead to it being a lot easier for these systems to be developed, especially and from our side as well, on just in our small piece of it, which is around 3D visualization. I can I know that that's going to get easier and easier as well. So I think it's just a timing thing. It's always possible to build the first one of something, but the cost is usually very high, right? Now, it's not that it cost us a great deal to build Dasher necessarily, but it's been a decade-long project, and with multiple people engaged on it at different times. But once these things get made into a platform and made more repeatable, it becomes more straightforward, and people will have more success doing it over time, I think, in a repeatable fashion. Now, overall, I can't really speak for the industry because I don't actually have great visibility on what's happening as a whole in this industry. I tend to focus on my development tasks and the research that I'm involved in. So that's, again, you have to take my perspective with a little pinch of salt there, I would say.
Yeah, but with that being said, where would you see yourself heading with all of this? Are you continuing in the creation of Project Dasher, or do you have some ideas and dreams within this whole world and area that you want to fulfill?
That is sorry, I didn't mean to cut you off with the last. That's an excellent question. I think it's probably a good segue into showing this, which is. It's not actually a recent slide, but it's one that I think is quite interesting in the sense it gives some perspective as to how Autodesk sees IoT and the idea of a digital twin, and how, yes, it's got value from an operational perspective, but it also has value in the way it can connect back into the design phase, which is where, of course, our main focus is today. So I also spend quite some time working on research projects related to generative design. So using tools such as Dynamo and Refinery to explore the potential for I would say automatically creating lots of variations or exploring a particular solution space for a design problem using genetic algorithms in order to find these very high performing solutions that score well on multiple different sort of metrics. So over time, and we're starting to see this happen more and more, is that the data that's collected from the real world and fed into digital twins will be, cycled back into the generative design process. So you can imagine a case where you design a building. You might use generative design to optimize the layout of that building, but then you may also have a system installed in the building which is monitoring how that building performs in reality, how people occupy it, what behaviors they have in the space, based on that configuration. So what we can do is take that data, feed it back into the generative process in some way, or have it influence the next iteration of that loop in order to drive a more efficient and higher performing next version. Now, next version could be a whole nother building, of course, or it could be a reconfiguring of that building. You may want to reconfigure every few years, or you might be a co-working space where potentially you want to reconfigure every day based on the projected usage of the people that you have coming in, based on the data that you have on the way they've used it in the past. And you can start to do some really interesting things with this kind of iterative, virtuous cycle where you're building something based on data, measuring how it performs in the real world, and then pulling that data back into the generative loop.
A good supplement for that sentence would be the question from James Hardy asking if Dasher can inform construction as it's being built in red green lights in the decision process of design, for example.
So I think a digital twin that's focused on that part of the phase could do that. I mean, Dasher our focus has been about bringing in IoT data into something that's relatively static in terms of a model. So we're focused much more on kind of, exploring the performance of the operations of a building, or, thinking about something that's already been built. Now, when you start to think about things in construction, it's a lot more dynamic. We have to deal with different, the model itself is a lot more dynamic. So I think absolutely there's a lot of potential for having a much more dynamic system that takes in IoT data and represents it in some way in a 3D context. But that's not really the focus that we have right now with Dasher, which is a little bit more static in that sense. But I think overall the opportunity is huge there. It's just that there are some building blocks that would need to get sort of fleshed out properly for that to be easier. Yeah.
Of course. It's a lot of capabilities that needs to be in the right place at the right time. It seems very very big and ambitious too. It's a project that has a very wide reach in the industry for many different purposes. Would you think that this is an Autodesk thing, or are you more thinking about Project Dasher and the movement around the project as an industry thing, as a part of general development?
So the question is, do I think about how Project Dasher relates into a bigger picture of the industry development?
Or is it rather Autodesk development? Of course, it's funded and it's an Autodesk project, but do you see it yourself as a general purpose for the industry?
So, I mean, there is a lot of interest in digital twins in general, right? So, I mean, people are, and again, and I go back to my original point where I said, well, in some cases, a digital twin could be something as simple as a spreadsheet, something that is just dealing with some non-graphical view of the world and is updated based on things that are happening, and gives you an idea of it gives you a certain view on that physical asset that you have. So I think that overall there is a trend towards, well, there's two things. I mean, well, there's lots of things, but I mean, we're involved mostly in the visualization of data, but in theory, you may not really even want to visualize data inside a digital twin at all. And I think there are people who are more focused on the data aspects of it and making sure that it, you know, that you have the data that's accurate for a particular physical device. We're focused on visualization, which means that we have this perspective that tends to be a little bit more visualization centric, because for us it's hard to imagine a digital twin that doesn't have 3D at the core of it, as I showed on my original slide.
It makes pretty good sense to have that as a core of it.
Well, we think so, but again, not everybody agrees. But I think that over time, whether you need 3D because the system is fully trained and can identify everything that's happened, you know, needs to happen, and managing the scenario or completely automatically, I think there's always going to be a value for having a tool such as Dasher or other more visual centric digital twins that allow you to explore anomalous behavior. When is something happening that you don't understand? You know, you don't really want to explore the things that have been categorized and understood already. You want the system to take care of those. It's the things that happen that surprise you, where you really need to have a tool that allows you to explore what has happened in the real world and find a way to address that in a more automated fashion over time. So I think that that's a space that will make sense for this particular type of tool in the future. It could also be used operationally, potentially for people who prefer to have a
VR,
3D
for
view.
example, VR goggles. Could I integrate my Dasher model with VR goggles or AR?
Absolutely. So I mean, we've done some experimentation around that. I mean, for me, in a sense, it's not really controversial. It's not that hard to do. The hard problem around that has always been around indoor localization. You know, where are you inside a building? What are you looking at? It's easy to have the data accessible, but what data do you need to show based on, you know, the context? So there are some things that are interesting there, but I've been waiting more to have other players in the industry solve the kind of indoor localization problem, because it isn't really something that Autodesk should be solving, in my opinion. But once we have that positional data in the various platforms, and I think to some degree it's getting there, whether you're on Android, iOS, etc., that you can start to get fairly good data about where you are in the world, even if you're indoors. I mean, GPS was a good step, of course, but indoors is a different problem.
I have a sentence from Gabby again here saying that if this is fully implemented in the building industry, would we risk ending up with such huge amounts of data that we needed to store in a way that could be maybe not a benefit for our operation? How can we sort the data that comes in? How can we decide what we keep and what is not relevant historical content?
That's really interesting, because I mean, we've tended to be of the opinion that we should just keep everything, because you never know what you might not want. Sorry, you never know now what may be valuable to you in 10 or 20 years, right? During the life, and we're talking about really significant lifespans of buildings. So our view has been always, and I think a lot of IoT systems have tended to run on a window where we said, well, anything 2 weeks, older than 2 weeks old is going to get discarded. We've tended not to do that, because we have this sort of fundamental belief that this data over time is going to have increasing value in terms of understanding. But there is also obviously that's more perhaps a research-centric view, where you're thinking, well, it's useful to have information on prior situations, but from an operational perspective, it may be somewhat irrelevant in the near, because you're no longer operating that building. Or whatever, so I think that there is obviously some sort of time span on this. I'm a little bit more optimistic about the fact that over time, between things like DNA storage and the different ways of storing data in an efficient way, there isn't necessarily a large cost associated with storing and serving up data. I think we've got more risk of killing the planet because of Bitcoin mining than we do because of storing IoT data, even if we're capturing and dealing with massive amounts of it. But that's my view on it. I think, as I said, I think I'd probably, if I was going to stop anything, I'd stop the Bitcoin mining, which is just using massive amounts of energy and computing resources to make money, I suppose. But yeah.
Somewhat money, right? But that's again a perspective on data, you could say, and this whole way of storing some kind of information that goes back and forth. And I guess that's why Gabby had the question about it. But does it mean that Dasher actually opens up a space for potential investments in Dasher data? Could I buy a share in the future of Dasher carbon data? A building because Dasher is the best tool to monitor the data, or how is that perspective?
No, I mean we've not really been thinking about it in those terms. I would say in terms of having thinking about. I mean, the goal has always been for Dasher to have some impact on the planet, positive impact on the planet, and to make buildings more efficient, make us more aware of when we're wasting. I mean, I think it's like 48% of CO2 emissions on the planet come from the built environment. I think that even if you make a really small percentage-wise impact on that, it's massive. The potential that you have for improving the planet. So I tend to think of. We're looking at it more in those terms now, whether it's Dasher or whether it's some other tool that somebody else is using to better automate systems. I'm not too worried about it in that sense. My personal aim is that, or I would hope that some of the work that we've been doing inspires other people to go and do other things that are of benefit, because it's not just going to be some technology coming from Autodesk that's going to fix the world.
Okay,
it's just not happening.
Now we are talking. That's why I wanted to say before whether it was Autodesk or it was the world, right?
Right.
Because of course we are talking about things here that is super exciting, and it's for sure a development that we will hear a lot about in the future, both in the close future and on longer terms. But it has some ethical things to it that needs to be clarified. And as I guess you already noticed, the questions coming in is kind of political, most of them. People are talking about the use in current buildings, or is it actually something that we're going to use with new buildings to sort of lower the pressure on the climate, or what is going on with this program? Is that being taken some statement on that perspective?
It's hard to know how to answer that, really. I mean, we're we have deployed the technology. I showed you the Kingspan building, so that's the most recent project where it's been deployed at a building that's just finished being constructed, and they've integrated some really interesting capabilities, including the 3D, the anonymized skeletons, so that you have visualizations of people walking around in 3D inside that space, which is really cool to have that not just on a bridge, but inside an office environment as well. I think it's very, very interesting. Now, why did I start talking about this? But again, but that is once again where we're using anonymization technology in a workspace, because we are sensitive to the fact that you don't want to be just storing video footage of people walking around and making that available and accessible.
Have some purpose, and it needs to be able to So what we learn from the Dasher data or the digital twin data, should I be able to sell and buy that for my building that I've been monitoring in order to improve my own capabilities of designing better, or a company's capabilities of designing better in the future?
See that, well, so the view that we've always had, and this is a general sort of data ethics question for a company like Autodesk, who's big, and you kind of at some point have a choice. Do you want to give away products and services for free in order to monetize the data, such as you have from I don't want to badmouth anyone, but Facebook and to some extent Google as well, where the monetization is through the data, and people see so much value in the tools that they willingly hand over their data. So, in our case, we provide tools for professional users who pay us for the, to make use of these tools.
Yeah.
And we have a responsibility that we're not just going to take the data that those tools generate and give them to their competitors. Now, there will be situations where of course, you can opt in order to get perhaps more benefit from your data and say, well, I'm fine with sharing this data more broadly because I will see more benefit from the data that other people have shared with. There's other ways to look at that, but it's always going to be done in an ethical sense of, us. It's not our business model to take this generated data that people have created and make use of it or sell it or whatever. It's just not. It's not how we're set up. But to increasingly use the data in an ethical way to provide insights to customers, to say, we have all this data from your use of, let's say, BIM 360. Here are things that you can do to be more efficient. Here are things that you can do to be more successful with using our technology. I think there are real opportunities around providing insights to customers in order to help them be more successful, but not necessarily, doing it in a way where we just, learning from everyone in order to benefit, people who have not. Anyway, you kind of see. I think I made myself clear before I.
Yes.
Okay, all right,
perfect. I get your point. And mine was just that it made very good sense to actually be able to easily use what we learn from our monitoring with these tools into providing our customers or our clients with new, more sustainable solutions in many different areas, of course. Kean, we have had a lot of great questions here at the end, and I just want to say to you that because we are already way over time, I just want to say thanks a lot for visiting BIMCafe. I'm very happy that you wanted to come by and talk a little bit with us about your project, your exciting project. A couple of things before we end this talk. If I'm a student and I want to go into digital twin, where to start then?
So I think there's, again, you said it yourself earlier, sign up for an AEC hackathon, find a team you can join, and decide where your skills might be, your focus. I mean, whether it's software development, whether it's some sort of domain specialty, bringing in. Anyway, so there's lots of ways that you can contribute to projects, even if you don't necessarily have software skills or software development skills. If you want to, as I said, the Forge accelerators would be a great way for people to really get a kickstart on using Forge to do things such as we've done inside Dasher. I think that there's, I tend to have those are the things that I'm most involved in myself. Personally, I would also, please, of course, follow me on Twitter or LinkedIn. I've seen a number of people have sent connection requests already, which is great. Straight away after this, I'll go ahead and accept them all. But that's a good way as well to get connected with, or to understand some of the things that we're doing in this space. And over time, I think there'll be lots more news about these kind of activities from, I think we're actually really early on in this journey. I know that the comment came in earlier, I think maybe from Gabby, who was saying that, yes, why isn't it here already? And I said, well, some people are very aware of this space and have been following it and have been expecting more from it. And I think this is a very traditional kind of the way that technology goes through the Gartner hype cycle, and there's a lot of interest, everybody thinks it's great, it's possible, but then of course reality sets in, and you get into this trough of disillusionment where, okay, this is actually harder than we thought. But I do feel that right now there is this, we're steadily making progress towards a point where all this stuff will be accessible and easy and actually boring. That's also the goal of this stuff, is like by the time it gets through to being productive, nobody cares about it anymore because they're focused on the other end of the hype cycle and thinking about what's new and shiny. So I do think that we're getting steadily towards the point where the technology is going to be broadly usable and applicable. So yes, we're at the beginning. I think this is a great time if you're a student and you have domain skills, of course, because you've just been going through your undergraduate studies in architecture or something else, architectural technology, but getting some development skills, whether it's self-taught or building on some lessons that you've had during your studies, you'll have a killer combination. Back to my original point where I said, well, I didn't have that going into university. I had a software background, but I didn't have a background in the industry. And that has been a hindrance. It's not been easy at times to luckily I've been surrounded by people who do have an industry background, so it's been okay. But you have an opportunity to combine these skills and to really help drive automation in the industry, which is an industry that really needs automation. So, do your best to acquire development skills, and it could be skills that relate to developing with Forge or using a tool like Dynamo or Grasshopper or what have you to do visual scripting. But think about sort of building out these skills, because those skills will be in huge demand in the future.
We do have a super good movement these days. We have a strong Dynamo department. A lot of news will come up about that. Dynamo Tuesdays and other kinds of events. We will do some hacking on our own, and we will try to do it together with the industry also. We do also have people who is interested in web development and software programming and such. So hopefully the killer combination that you're talking about will suddenly blossom, and we will show that we're able to contribute and making some new development in the industry. Kean, it's easy to tell that you have a lot of knowledge and experience. On a personal note, before we wrap this up, can I ask you, how come you stayed with the AutoCAD so long? On Kia, we dropped it like in 2006 or something. What happened?
So with AutoCAD itself or Autodesk, or why? So AutoCAD is an incredibly powerful. I mean, from a development perspective, the API set, the flexibility that you have allows you to do some really incredible things that, in fact, many of our other software tools don't give you that same flexibility. Mm-hmm. So for me as a developer, it's an extremely productive environment to be able to build additional tools. So, I had a great run with it. I've been doing other things for the last 5 years, but Autodesk as a company has managed to keep me engaged and interested. I mean, my main, and I've done a few podcasts that are linked to on my blog in case anybody's interested. I'm happy to send the links through. Be if you're interested in my motivations, one of my core motivations is to have fun every day. I don't want to be, if I was focused on either making money or, well, I mean, money's important. You need to be able to feed the family and put food on the table, of course. But if I really wanted to get rich, then I probably would have gone and worked it. I'd be working at a bank. But that's not inspiring to me. It's not interesting. I don't care about making rich people richer. I care more about helping provide technology to people who are solving the world's biggest problems. So that's, I get motivated by that, and working on technology on a day-to-day basis is cool. I just have so much fun doing it. So That's ultimately been my driver. So whether it's been working on AutoCAD, which was great fun, which is working in research, which is also great fun, that's ultimately been why I've stayed with this company, the amount of time that I have, and why I'm still working with this kind of technology.
Yeah. Kean, I just want to say that I'm super proud that Kia BIMCafe is able to host a talk with people like you who has this history and background in the industry. I'm sure that a lot of students is going to benefit a lot from it. I'm happy to hear that people already tried to reach out and connect with you on LinkedIn, and I hope, guys, students, also professionals for that sake, that let's please all of us contribute to the discussion about how to develop this area. It's surely very exciting, and it's for sure something that we are going to have some focus on in the future. Kean, the last thing, can I maybe contact you once again in a year and invite you for BIM talk number 365 to ask you how is the development about Project Dasher once again?
Absolutely. Reach out at any time. The worst that can happen is that I'll tell you, we haven't really made any progress in the last year, or, unfortunately I'm too busy and don't have time. But I mean, I don't imagine that will be the case. I'd be more than happy to come back and talk to you all again. So I just brought up the first slide just so that once again, people can see it. For people who may have joined late and don't know my name, there's my name and Twitter handle and email address. And you should be able to find me on LinkedIn pretty easily as well.
And if you want to find me to hear more about new talks and things that is going to happen in the future, please go to the BIMCafe LinkedIn page. You already know that, or you can find my address for my profile in the chat. With that being said, thanks a lot, Kean. Thanks for today, and thanks to all of the audience who chose to spend some time with us today here. Thanks a lot. That's it.
Thanks, everyone.
Okay. Yeah.
Take care. Bye.
Take care. Bye-bye.